Welcome to this platform. So in this video, let us continue answering Science Paper 1. So we are answering Science Paper 1 Section B, and previously we answered question B1 and B2. So in this video, we are going to continue from B3 to B6. So here is the first question that we are answering. A glass-sided box containing a mixture of smoke and air is illuminated and a microscope is used to view the motion of the smoke particles. Question A, Roman numeral 1, define diffusion. So the first question, we are simply going to define diffusion. To define diffusion, we are going to say diffusion is the movement of particles from the region of higher concentration to the region of lower concentration across the concentration gradient. So is the movement of particles from the region of higher concentration. So from the region of higher concentration to the region of lower concentration across the concentration gradient. So that is how you simply define diffusion. Okay. Then the other question is state two factors that increase the rate of diffusion. What are the two factors that increase the rate of diffusion? So one of them is the temperature. And you should know that the increase in temperature increases the rate of diffusion. And behind that, you should be able to explain the kinetic theory, diffusion in terms of kinetic theory. Okay, the other one that we can look at is surface area. Okay, surface area is one of the factors that increase diffusion. Then we can talk also of concentration. Okay, concentration is one factor that we can look at also that increases the rate of diffusion. Then B question, state two differences between boiling and evaporation. So what are the two differences between boiling and evaporation? So we can start. So boiling, the first one that we can say, boiling takes place. So boiling takes place at a particular temperature. And that temperature is called the boiling point. Okay, so it takes place at a particular temperature. Then you can say, wow, evaporation takes place at any temperature. So evaporation takes place at any temperature. So be able to finish this. So it takes place at any temperature. Then the other one that we can look at is boiling occurs throughout the liquid. So boiling occurs throughout the liquid, while evaporation, so evaporation just occurs on the surface of the liquid. So evaporation occurs at the surface. Okay, at the surface. Then the other one that you can put, you can say during boiling, bubbles are formed. So during boiling, bubbles are formed, while evaporation can occur without bubbles. So these are some of the differences between evaporation. So if you write any of the two, you'll be given full marks. Okay, so we're up to B4. So B4, we are saying figure B4.1 shows the displacement distance graph for waves generated on a string. So now we have this part for displacement, then we have distance going this side in centimeters. The first question is define the wavelength of a wave. So what is wavelength? So wavelength is just the minimum distance at which a wave repeats itself. So the minimum distance at which a wave repeats itself is what we call the wavelength. You can also define it as the distance between the successive crest or troughs, or the distance between the crest and the crest, or the distance between the trough and the trough. You are still correct. Okay, so those are the ways that you can define a wavelength. Then the second question, which is B, state the wavelength of the wave in figure B4.1. So if I look at the figure here, the wave, we are just looking at the minimum distance at which the wave repeats itself. So in order to look at the wavelength, we said it can be the crest and the crest, this is the wavelength, or if it was going like that, the trough and the trough, this is the wavelength. By the way, the wavelength you denote by this symbol which is called lambda. So this is for the wavelength. But you should know also that a wavelength is the minimum distance at which it repeats itself. So also this is the wavelength. So in this case, we are going to look at this. Okay, so a trough, a crest and a trough make one wave. So the wavelength therefore is 10 centimeter. Then what is the amplitude of the wave? The amplitude, okay, is the maximum distance here. Okay, it's the maximum distance from the resting position. So the resting position is this line. Then the maximum distance here, or displacement, also there, this is the amplitude. Amplitude is denoted by the letter A. So that is the amplitude. So the amplitude here is from there up to there, or from here up to there. And of course you can see this is 10, this is negative 10. Now this is distance, so it's never negative. So the displacement therefore is also 10 centimeter. Okay. Question D, if the waves travels along the string 0.5 meter per second, calculate the period of the wave in figure figure B4.1. Now the question is calculate the period, and also you need to know what a period is. So a period is just simply the time taken for one wave to form. So the time taken is what we call the period. Time taken for one wave to form is what we call the period. Then of course, to calculate the period, if we are to calculate it, we look at time, divide number of waves. Okay. Alternatively, you can find the period as 1 over frequency. Now what we are given here, we are given speed. There's a formula that connects speed of a wave and wavelength. Speed of the wave and frequency. So we are going to use the way where we start by calculating frequency, then now we can calculate the period. So here is the formula that I'm talking of. So frequency multiplied by wavelength. So this one is one that connects the three. Since you are given that the speed is this one, then of course the wavelength, we found it, which is 10 centimeter. Okay, so now we can use the wavelength and the speed. Now look at the speed is in meter per second and the wavelength is in centimeter. So we need to convert it into meters. 1 meter is equals to 100 centimeter. What about 10 centimeter is equals to x? It's just the same as dividing 10 divide 100, which simply give us 0.1. So therefore, the wavelength in meter is 0.1 meter. I guess you have no problem on conversion. Okay, so you cross multiply here and finish it. You find the value of x, you still find this one. So now we can replace in the formula. And now we have 0.5 meter per second equal to frequency, then wavelength is 0.1 meter. Want to find frequency, so you divide 0.1 meter, 0.1 meter. Okay, so here we are going to have this goes and therefore our frequency is equals to 5 frequencies measured in hertz. Okay, so 5 hertz. If we were to divide 0.5 divide 0.1 to give you 5, I guess I'm right on that one. Okay, now have we answered the question? No, we haven't answered the question. The question is period, so I wasn't supposed to put this one here. I should have put this one, frequency is equals to 5 hertz. So now, since that we have the frequency, we can say period is equals to that is 1 over frequency, which is just 1 over 5. This one, if you are to find the answer, you're going to find 0. That is 5 into 1 is 0. Then 5 into 10 is a 2. Period is measured in seconds, so 0.2 seconds. So that is how we simply work it out. Now, you need to show your working, because look at this. These are 3 marks. So all your possible working, you start by finding the frequency. You show how you found the frequency. Then you write the formula for period. You show how you find the period. I guess you wouldn't fail to do that. Then now we go to question 5. Okay, like I said, we are going to go up to B6. So this is B5. What type of energy is infrared wave? So what type of energy? So this is heat, or you can say, it's just simply say heat energy. Okay, heat or heat energy. Give the range of frequencies audible to the human normal ear. So normal human hearing, the frequency range is from 20 hertz to 20,000 hertz, or from 20 hertz to 20 kilohertz. Okay, so that is the audible human hearing. Then define an echo. An echo is the bouncing back of sound. So you can say the bouncing back of what? Of sound. That is wave. Or we can say, that is echo. Echo is the bouncing back of sound. Or we can just say is the reflected sound. Okay, so we can just say it's a reflected sound. Is a reflected sound. Okay, then a plane sends, that is we are on question D. A plane sends an ultrasonic sound down to the ground and receives the echo after 4.8 seconds. How high is the plane above the ground? Take the velocity of sound to be this one. So how high? So this one, they are talking of distance. Now, if you look at what you are given here, we are given the speed, which is 240, and we are given the time. This is echo. Okay, that was echo. So now, how do you find distance? How do you find speed when you have an echo? So speed is equals to 2 multiplied by what? Distance divide time. Or we can simply say S is equals to 2D over time. So this is the formula for speed when you have echo. Now here they are saying how high, which means you want to find the height, which is the distance. Okay, so to find the distance, you can make D the subject, or you can just replace. So I prefer replacing. So 340 meter per second equal to 2D. Then over the time it took was 4.8 seconds. Then you are going to cross multiply, and you are going to have 2D is equals to 340 meter per second multiplied by 4.8 second. Here we divide it 2. So therefore D is going to be 340 multiplied by 4.8 divide a 2. We should be able to find 816 meter. So just confirm on this part. Okay, then the other question, which is question E, give one way in which sound pollution can be minimized. So how can you minimize sound pollution? One way you can minimize sound is by using heavy curtains. Okay, using heavy curtains. You can also talk of using soundproof in the rooms. Okay, so using soundproof. I'm sure the design of the houses now, they have soundproofs. So using soundproofs in rooms. Okay, they are quite different. So you are going to add some ways we can minimize noise pollution here. So please be able to comment with your answers so that we can all learn. Okay, and of course your contribution will be highly appreciated. Okay, so here is the last question that we are answering, which is B6, and this is light. So figure B6.1 shows a lens used to form an image, okay, drawn to scale. So this one is drawn what? To scale. The first question is that identify the type of lens in figure B6.1. What type of lens is this? Okay, so this is called convex lens or converging. Okay, and this is because it causes the rays of light to meet or to converge. Okay, mention two characteristics of the image formed. So when the image is formed, this is the object that you are able to see here. When the image is formed on the other side, and of course the rays of light meet, these are rays of light, they meet here. One thing you should know, that the image is real. Then also they are on the opposite side, the image and the object. So the image is upside down, okay, or inverted. Then you can see from here, the object is between 2F and F. Then this one is beyond 2F. So which means we have large distance from here compared to there. So this one is magnified. Okay, so we can say bigger than the object, or it is magnified. Okay, so that is how you simply look at this. Then they're asking now the other question: what device uses this type of lens to produce a similar type of image? So I can put the projector, okay, as one of the device that use this type of lens. Okay, so even here get to add some more device that we can look at here. Okay, now as we end, let me just give you the question that you are going to answer. Okay, and the question is on electricity. It's a simple question, so please be able to answer this question and be able to comment your answers. All right, so we can end here. So please, if you've not subscribed to this YouTube channel, make sure that you subscribe, turn on the notification bell, that whenever we post the new material, you'll be notified. Get also to invite others to this platform. See you next time.